So Paulo, we're here, NodeConf 2022 live, which feels good to be back at a live conference. I've been missing that.
Yeah.
I was glad that things are online, things are still happening, but when you're here and you feel the energy, people seem really happy to be here. Tell me, where did you travel from to be here at NodeConf?
Well, I traveled from Berlin.
Okay.
I live in Berlin.
Okay.
Although I came from New York before that.
Okay.
And before that, California.
Oh boy.
Yeah.
It's a long trip.
Well, no, it's not a trip. I actually live in Berlin, and
Okay.
and I've been there for a while.
Okay.
Kind of strategically for the work that I'm doing.
And what is the work that you're doing, and
Well.
why would that be strategic to Berlin?
Well, so I'm working on a new runtime.
Okay.
The new runtime allows web developers with just HTML, CSS, and JavaScript
Okay.
to create cross-platform native applications that can
Okay.
communicate directly between each other.
Okay.
And they don't require any servers.
So a full peer-to-peer
Yeah.
technology
For web developers.
for web developers. And you said they're native, so we're talking about portable devices or desktop.
Yeah. So you can build applications by creating, HTML, CSS. But you use your favorite front-end development framework.
You use React or
Yeah,
Svelte
and then
or-
our framework, our tool will take that, and it'll bundle it up and take the runtime and put that all together into a native package so you can deploy that to a fleet of devices, or you can make it downloadable and people can install it, or you can even have it installable from other applications. So,
interesting.
Yeah.
And could you, or one day would you be able to put into the various app stores and stuff like that?
Yeah, definitely. You could do it today, yeah.
Oh, okay.
Yeah.
Okay.
In fact, today I just open sourced it. Open sourced it during my talk.
I was actually there, and it was
Yeah.
a dramatic
Okay,
event
Yeah.
to see you get open sourced in front of everyone. I love those when things like that happen at NodeConf, like you feel like you just witnessed something special.
It's nice. I mean, I feel like NodeConf over the years, and the American NodeConf and the European one have definitely attracted some really interesting outside thinking that has been based on really good science, and it's been based on some really great, hard work that builds on a corpus of really amazing prior work.
We have this really welcoming community, people who are really passionate about Node.js or any kind of JavaScript language, and it just attracts these forward-thinking people.
For sure. Node, I think, okay, so the story about Node that's really interesting, right, is not really the thing that a lot of people think it is, right?
Yeah.
I/O being efficient, that wasn't really anything anybody cared about. Right. It's a great thing, but no one really cared about it.
Yeah.
What people really cared about was that there was these millions of front-end developers, and they saw a pretty reasonable runtime, and it was, the example was, Hello World example was great, because they had that aha moment where they said, oh, I could do this. Right? No one cared about how the I/O worked, really. Maybe some people did. It helped to push it along, but really it was about empowering this very large audience of people to have complete control over the whole stack.
Absolutely, yeah, because it's very democratic and community-driven.
Yeah, and you had this really dumb term, but it kind of made sense, which was like an isomorphic, JavaScript. You run JavaScript on the server, run JavaScript on the client, and suddenly you have this sort of very, very, very symmetrical code base, and people were really happy about that.
Yeah.
And so, that's why we didn't really see Dino explode in the way that Node did, right? Dino is a sort of incremental improvement of Node. It's sort of ergonomically better. It's debatable, but now you have things like Bun, right? Which is performance-wise, it's smoking both of them, right? But I don't really think that matters as much,
right?
Because performance actually of fast servers matters so much less when we're starting to do fewer round trips to the server.
Absolutely,
right?
yeah.
We're doing fewer and fewer round trips back to the data center as more and more of the machine learning and the processing and all of the creation of the data happens outside the data center. It happens in a peer-to-peer network.
Right.
Right. We just haven't really formalized this yet, and so that's what I've been really working towards is creating this ability for the average web developer to create peer-to-peer applications and just not need servers.
So this is the runtime that you just open sourced today.
Yeah.
It's really geared towards peer-to-peer communications, like getting us away from the reliance on centralized servers. Is that?
Yeah, I mean, we want to have autonomy. We want autonomy. We don't want to have 10 different AWS services that are strung together, who knows how. I mean, the thing about cloud is that it's not deterministic. We don't really know how it works. Right?
It's a lot of...
I can create a distributed system that is complex, but it can be formally verified using something like TLA+. Right? So Leslie Lamport, famous for Paxos and logical clocks and all that, he created a language called TLA+, which, there's no universal standard. But this tool gives you the ability to create formally verifiable specifications about how a system works. So it can be, you can run a checker on it, and it can be determined to be deterministic. Whereas I can't do that with the cloud. I don't know how the cloud works. No one does.
The secret's,
it's a secret, yeah.
We use it, we love it, but we don't know what happens.
Right.
So as our devices get more powerful, our phones get more powerful, our computers get more powerful, if we just communicate peer-to-peer...
Yeah, they can just connect directly to each other. I mean, it's interesting to think about, the proliferation of hardware. Right? There's about 15 billion devices in the world at this point, right? And Amazon altogether, with all their data centers and everything like that, just Amazon maybe has about 3 million servers, right? And it pales. I mean, there's easily more compute and storage capability outside of the data center than in any data center combined. And to be fair, all of these devices that we're talking about are really low power, statistically low power. They're not always on. They have different security settings. They, they may have different battery levels at different times. So you have to consider all of them unreliable. But even looking at it as pessimistically as possible, you still have a network of devices that create a more robust overall network than any data center.
There's just so many resources available. So you see this as like the future moving forward.
I think it's
get rid of the Web 2.0
computing
model of, we're all reliant on some cloud storage, cloud data providers, cloud resources, and make that distributed between everybody. Like, what's... What do you think this is going to unlock for us as devs or people watching this?
I think that the big value proposition for developers is that, we're just buried in complexity. It's the DevOps work that we do. The cloud is a house of cards, and the products that we've built on top of them are incredibly complicated. The sheer manpower, womanpower, people power that it takes to maintain and understand these systems, it's not sustainable.
You have to hire resources onto your team just to manage the resources that are run by some other provider.
And those, like, the complexity is compounding. Right, so sure, you string together 10 AWS services, and it's no longer just the complexity of each AWS service, but how they fit together, because those are arbitrary decisions that can be made by a developer, right? And then that developer creates tribal knowledge. Maybe they don't document it. You're lucky if they do. If they do, can anyone else understand it? I mean, we're buried in complexity. And the thing is that peer-to-peer's complexity is finite. And it's finite, and it's a constant. It's a constant level of complexity. Because after you do hole punching, after you do some replication, after you figure out the basics, it's the same level of complexity. And it's, like I said, something that's verifiable. So
this is so exciting. So I want to know, what's the name of this new runtime and the framework that I saw open source today, but for anyone watching this video.
It's called Socket.
Socket.
So like it's called Socket because it provides sockets. And what it, just to kind of give like, a visual on it, it's imagine, you have the browser UI, right? But just a tiny core of it.
Okay.
And then into the JavaScript, you expose UDP, you expose Bluetooth,
Okay.
you expose a proper file system.
Okay.
You know, these things that browsers don't and won't have.
Won't have, yeah.
Right.
Yeah.
And I think and then so you know today it's based on libuv, parts of libuv, but that could change.
Sure.
It may be that maybe we write something from scratch that's a little bit more up to date. But you know, I think that like libuv is really well tested. It's really stable. It's a good pick for now for starting off.
Well, that's a
and I
good
think
place to
like when
start,
you
yeah.
compare this to other types of things too, because the first question most people ask is like, how is this different from Electron? Well, Electron only runs on the desktop.
Right.
PhoneGap only runs on mobile. You have some kind of entrance into the space like Tori, which is largely based around Rust. You need to understand Rust. It doesn't work on mobile at all yet.
Yeah.
I think that they're experimenting with it, but it's been years coming. You have some other kinds of things, and the problem with these is that they're as big of a code base as Electron, right?
Yeah.
And the code complexity of the project matters, right? So Tori's code base is quite large. There's one called Electrolino, which is even bigger than Electron, right?
It already takes long enough to start up.
Yeah. So like, it's cool to be targeting cross-platform stuff, but it's even cooler to be targeting like an entirely different approach to building the web and taking an approach that dramatically reduces the overall complexity of the systems that we're building.
Yeah. Now, in your talk today, you mentioned like the size of a binary that's built with this technology.
It's weighing in at about a 1.5 megabytes.
And that's for which platform? For
that's on Mac.
a Mac.
Yeah.
Wow.
And about 13 megabytes on iOS.
Which is just kind of insane.
And this includes like our front end stuff and all this other kind of stuff to make an application.
Wow. Wow, this is amazing. So just in the last minute before we go, can you give us like a teaser about what might else be coming from Socket or things maybe on the roadmap? Or
so we have a bunch more interesting peer-to-peer stuff coming, like tools and just various things that people are going to be interested in when they start thinking, maybe I could reduce my cloud bill. Maybe I start thinking about how I integrate a little bit of peer-to-peer to supplement my existing cloud services.
Like a phased in.
Yeah. And so we're going to be producing like a bunch of interesting tools around this.
Cool.
We've already started working on. They're kind of in alpha. Really, the next couple months is about tightening up the framework. It's very alpha at the moment, but we expect to be into production mode very, very quickly.
Wow. Yeah. Paulo, that's just so amazing. I'm so excited. Like when we're done, we're like, go get my laptop out and start seeing what I can build peer-to-peer.
Yeah.
Thank you so much for being here.
Yeah,
and I look forward to all the exciting stuff coming from Socket. Thank you for your time.
Yeah, thanks you.